Okay. Because I knew Brady was going to watch it, and I messed up. Okay. So, since I messed up yesterday's video, I'll do a quick refresher here of the different transformations that we talked about yesterday. Okay. This is not new. Remember, we talked about transformations when we did quadratics, right? We shifted those parabolas up and down. We shifted the parabolas left and right, okay? We vertically stretched them or shrunk them. We horizontally stretched and shrunk them. Flipped them too, okay? We did all those things. And these kind of transformations, folks, you're going to see it again and again, okay? So the sooner you learn these, the more easier your future math career is going to go, right? So like future you will thank you, okay, for learning these now because you will see them again for sure, all right? So the sooner you can understand that when you add something to the function outside, that's a shift up. When you subtract something outside, that's a shift down. When you add a k on the inside with the x, okay, that actually shifts you left k units, right? And then when you subtract a k on the inside with the x there, that shifts you right k units. So that's like the opposite of what you'd expect, right? Plus k shifts you left, minus k on the inside shifts you right, right? And that's all from what we talked about yesterday. Okay? You will see this again and again. I'm teaching Algebra 2 right now. We're doing this exact same thing in Algebra 2. Okay? Yep, similar. It's similar stuff, right? Yeah, we just got through quadratics as well and stuff like that. Okay? I know, I need to do that, yeah. I've been calling my Algebra 2 students in, so I'll get you in there. I'm sorry. In fact, I'll put a note to myself here. Not tomorrow, but I'll do it for Monday, though. So, okay. So, any general questions here about these different transformations that we have? Okay. So again, the plus 3 here. Oops, sorry, I'll do it this way. Okay. So we have in this case f of x plus 3, and what's our f of x? In this particular case, we said f of x was 2 to the x. So the plus 3 means we take that 2 to the x, we shift everything up 3. So there's our normal 2 to the x, and we just move it up 3. Okay. Here it's f of x minus 2, so we take our normal 2 to the x and shift it down 2. Here's f of x plus 4. The plus 4 is on the inside of the function, so that means we're going to shift things to the... A plus 4 inside, folks, means we shift things left 4. Okay, so you can see there's my normal y-intercept, and I go left 1, 2, 3, 4, and there's my point. Right, there's another point right there. I shift it left 1, 2, 3, 4. Okay. That's called a translation in geometry. Next year when you take geometry, you'll be doing translations or slides, right? All right, here, a minus 2 means we're going to shift right 2. So again, just take every point, move it right 2. Okay? And get your new coordinates. And then the last but not least, we have this transformation right here, the negative f of x. Okay? Now, what is that negative going to do? So, Alex? Yes, reflection over the x-axis. Okay, if you don't believe me, I'll show you here. So, in the case of our example, remember f of x was 2, so it's going to be negative 2 to the x. Okay, now we got to be careful here. In this case, we don't want to put the negative in with the 2. So it'll be negative parentheses 2 to the x. So let me show you here. Okay. Like there? Yep. Okay. So I'm going to put this in my graphing calculator here. Okay, let's see if I can get this to all fit. Question? Yes, sorry. Thank you for waiting. All right, so we'll put in the normal 2 to the x, and I'll put the negative 2 to the x. Okay, and graph it. Okay. So there's 2 to the x, right? Normal exponential function, and there's negative 2 to the x. Okay. Yeah, it creates some sort of like fun shape there, you know? Like a horn. All right. So, this is a reflection over the x-axis. Okay? So, how do we take this graph and reflect over the x-axis? Well, pick a point, like this one right here. Okay, I'll zoom in some there. Okay. Pick a point like this one right here. Okay, so we have the point 0, 1. And again, we're going to reflect over the x-axis. So this point is 1 unit away from my x-axis above it. So it will reflect 1 unit below it down here. Okay, so there's a point, right? This point right here is 1, 2, right? It's 2 units above my line of reflection, my x-axis there. So I'll go 2 units below it to right there. Okay, and this point right here is 2, 4. So again, I'll go to 2, -4 then for the reflected point. Okay, at -1, I get a 1/2, so it reflects down to -1/2. And this one will be like right in there, and so on and so forth. You get the idea, I think. So I'll connect those dots. Like so. And voila, we have our reflected curve. Okay. Now, if I happen to teach you guys in geometry, we also have these fun little things called mirrors that actually can do reflections as well. But we're not going to worry about that right now. Okay. What is the domain of this red curve here? What's the domain? -infinity to infinity still, that's right. Okay, what about the range? What's our lowest y value here? -infinity up to 0. Okay, so our range changes here, right? Have any of these transformations affected our domain? No. And some of them have affected our range, but some have not. Okay, this one affected our range for sure. Okay, -infinity to 0 is our new range there. And what's our asymptote? Do we have an asymptote for this one? It's still y equals 0 again. Yeah, it's still that line y equals 0 because it's going to approach that 0 line. Yeah.
How did you get the 0 for
This right here? So if you look here, right, so you're okay with -infinity, right? The lowest y value is going to be -infinity, right? But then as we go up higher and higher, higher and higher and higher, we're getting closer and closer and closer to that x-axis, which is a y value of 0. So that's why we get to the 0 there. Potentially, you will have to. Not for every single problem, but it's a question that you should be able to answer, yeah. Okay? Of course, domain's going to be easy. -infinity to infinity every time. Okay? Later in this class, we'll get to some ones that don't have -infinity to infinity every time. All right, questions? All right, so that's it, guys. Just 5 transformations. These transformations carry through for every function we're going to run across. Square roots, absolute value, quadratics, cubics. Okay, what's that? Yeah, like little pointy ones, right? Okay, so we're going to be using this again and again, okay? You'll see it in Algebra 2, maybe a little bit in Geometry 2. Okay, so please, if you get these down, it'll be helpful for your future self. All right, let's turn our paper over here and let's try B and C. We'll do these together, and then I'll probably have you guys do B and C here on the bottom on your own. Okay, so let's look at B and C here. Okay, we'll focus in on B first. Okay, so B, we're taking our function f, and we're going to make it x minus 3 and then minus 4. So again, our function f here is this 3 to the x. Okay, now, I was working with Hannah a little bit in set, okay, and so I want to make sure we get this right because this one's a little bit tricky. We have a couple of transformations happening here. Okay, so notice, this x minus 3, this minus 3 is in with the x. So when I go to write my new function here with the transformation and stuff like that, it's going to be 3 to the x minus 3 power. Okay, see how the x minus 3 is inside the parentheses there with the x, right? It's x minus 3. That's going to go and replace our power here. So it's 3 to the x minus 3 power. Okay, and then the minus 4 goes on the outside on the main kind of line there. Okay, x minus 3 in the exponent, minus 4 on the outside. Okay, so Anna W., what kind of transformations do we have here, Anna? Down 4. And then right 3. Very good. Down 4 and right 3. Awesome. Yeah. So I'm going to put that this way. Okay. Right 3. Guys, remember, this is the tricky one, right? The number in with the x is the opposite of what you'd expect. A minus 3 should go right 3. And then a minus 4 on the outside. That is what you'd expect down 4. Okay, so there's your right 3. There's your down 4 right there. Okay. So now to graph this, right, we're going to take our normal, so the y-intercept for this graph is going to be what? For the plane graph of 3 to x, what's the normal graph what's the normal y-intercept for this graph right here? What's the y-intercept for this graph right here if we wanted to graph it? Go ahead, Anna. It's 1, right, folks? It's the a value, right? B is the 3, a is the 1 there. That's in front. We don't see it, right, but it's the a value of 1. Okay? So my y-intercept would be 1. But I got to transform it. So this y-intercept at 1, it's going to move which direction, folks? Down how much?
4.
Yep, down 4. 1, 2, 3, 4, and? Right 3. 1, 2, 3. There's my new, that's where my y-intercept moved to, right there. Okay? So that's my new y-intercept, 3, negative 3. Okay? If you want to then, you can make a little chart. Okay? We'll put the 3, negative 3 in the middle there. And we can type this into our calculator, or we can just pick some values. So I'll do 2 and 1, and I'll do 4 and 5 there. Okay? I'll do the easy ones here just in our heads, right? So we'll plug the 4 in. What's 4 minus 3? 1. What's 3 to the 1 power? 3 to the first is? 3. Take away 4. What's 3 minus 4? Negative 1. And so we get negative 1 for our y value. Let's plug in 5. 5 take away 3? 2. What's 3 squared? 9 minus 4. So we get the 0.55. Okay? And then I think this is going to get too little tricky with the 2 and the 1 there. So I'll go ahead and go to my graphing calculator and do that here. Sorry? I'll show you here. No problem. All right, so we're going to plug in 3 to the parentheses x minus 3 minus 4. Okay, just like that. You have to put parentheses around your power, especially if you have like the not so pretty type. Okay, in. We'll go to the graph. Okay, there's our graph. And we'll do second graph, and there's our table then. That's what you want to look for there, Trey, the table. Okay, so 2 is negative 3.6 repeating. And then 1 is negative 3.8 repeating, it looks like. Okay? So let's plot these points then. We already have the 3, negative 3. Let's do 4, negative 1. And 5, 5. Okay? And it'll do 2, negative 3.666. That's like a little bit more than halfway. And then the 1, negative 3.8. Okay. Now, one other thing I want to graph on here, I want to graph my asymptote. Okay. Where is our asymptote normally for the normal parent function here of 3 to the x? Where would the asymptote be normally? At y equals 0. Exactly right. But if we shift it right 3, is that going to affect our horizontal line? If you move a horizontal line right 3, it doesn't move it, right? But if I move it down 4, now where's it going to be? It was at 0, now it'll be at negative 4. So I'm going to draw my horizontal asymptote there at negative 4. Okay, just a dotted line. And so now you have your boundary line, right? You can see, oh, okay, there's my curve, and it's going to go then intersect there, there, there. And I'm just going to kind of bottom out and head this way. And we'll go up to there. Question? Asymptote, well, yes, actually, you can think of it that way, yes. Yep, if it's a minus 4, it'll be negative 4. If it's a plus 4, it'll be positive 4. If there's no number, like there is no number here, right, it'd be 0 then. Yeah, you can think of it that way if you want to. Sorry? That's how you can find it easily, you get quickly. Okay, so therefore, what's our lowest y value we're going to approach here? Negative 4. And what's the highest y value we go to? Infinity. Okay, and there it is. Okay, there it is. Okay. Let's take a look at letter C then. Okay, letter C. So, negative f of x means we're going to do negative 3 to the x, right? Just put a negative in front. All right? And that transformation, Alessandro, what's that negative do again to our function when we put a negative in front? Is what we just talked about here. Yeah, take a look there if you need to. Reflect over the x-axis. I'm sorry, it's supposed to be the x-axis. Yeah, reflect over the x-axis. Oh, that is... There we go. Reflect over x-axis. Yeah. See, there's no, so we're not shifting at all here, right? There's no number on the outside that we're adding or subtracting. There's no number in with the x that we're adding or subtracting. So we're not shifting left or right or up or down at all. It's just a reflection. Okay? So, let's see here. So the normal y-intercept, again, for this graph is what? What's the y-intercept for the normal graph here, untransformed? 1. Okay. If we reflect that over the x-axis, though, where is it now? -1. So put that point right there at -1. Okay, we'll make our little chart here. Put the -1 in the center. I'll do, whoops, not -1, it's 0, my bad. 0, -1 is the y-intercept. I miswrote that. My apologies. So we'll go 1, 2, we'll go -1, -2 like that. Okay. Again, the ones after the 0 here, I think we could do mentally, so I'm just going to do that. So let's plug 1 in. What's 3 to the 1? 3, and that's just -3 for the answer, because it's negative in front. What's 3 to the 2? Careful. That's 3 times 2. What's 3 to the second, or what's 3 times 3? It's 9. So it'd be -9 then. Okay. For these other ones, it's a little bit trickier. So again, we'll go to the graphing calculator here to help us. All right, I'll just type in -3 to the x, like that. Go to the table. So -1, we get -1/3. And then for -2, it's going to be -0.1 repeating. That's actually -1/9, if you like, or if you don't like. Okay, so we'll graph 1, -3. And then 2, -9, womp, womp. It doesn't fit. I'm going to kind of eyeball it, though. So that there's 7, 8, 9. It'd be like right there. Okay? And then we'll plot -1, -1/3. And then we'll plot -2, -0.1. So just like that. So now, Grayson, remember, he asked the question, right? Is the asymptote just the number at the end, right? So what will our asymptote be here for this situation? 0. It didn't shift up or down. The asymptote is still 0. And so I'm going to draw in that asymptote here right on the axis. Okay, just like that. And then we'll just connect the dots and have your graph, again, get closer and closer to that asymptote. Okay, there are situations where a graph will cross a horizontal asymptote, but not in our case here with these exponential functions. Okay, so we don't have to worry about that. Okay, so Cameron, what's our range here? What's our lowest y value, Cameron, for this graph? Yes, sir, -infinity. And what's the highest y value, Cameron? We're going to get closer and closer to 0. We never get there, so make sure you put that parenthesis there. There's our answer. Okay? Questions on any of that? All right, then I would like you guys to try letter B and letter C down here, okay? And you're using this as your function. Okay, that's your F. Yeah, go ahead. Okay, so go ahead and try B and C, and you're using this one as your function here. Okay, so see what you can come up with. Yep, I'm sorry. Oh, yeah, I got you. Scott. All right. Let's leave that right. Okay. There you go, sir. Yes.
Right next to it or above it? It's in parentheses above it. That's when you have to do that. And then put X. Right?
All right, let's see.
So it's going to keep substituting with that here. 1, 2, 3, 4. Okay?
Yeah, you set it up perfectly there.
Yeah.
So then, you don't start here, it's 1, 2.
so then we have the second and that table.
So transformation.
So this will give us some key
You have
points.
x plus
Remember, you don't
5.
have to plot them all.
So since that plus
This
5
will also
equals
double
x,
check.
it's gonna
Now,
shift
the
left
only
or
thing we
right.
have to double check is,
Right?
so
the
see how
plus
his
5
parentheses
is gonna actually
was
go to
around
the
the 3,
left.
and the negative was on the
Plus
outside.
4 is going to go.
So this would change.
No, actually, this one does do what you
Yeah.
expect. It
And I
goes up.
think- yeah,
So
I
it's
think
going
that's
left
gonna-
5 up. So what you would do, so back up real quick then. We look at our normal function we have here. So we're going to take this one, we're going to shift it left 5 and up 4.
Now, let's
So
do it, let's do
for this
negative
function,
and then parentheses.
2 is your y-intercept.
Puts a 3 in
This
there.
number in front
Yeah.
is your y-intercept. Just like up here, the number in front, well, it's
And
number
then do raise
1,
that
right?
up and put that. See if that makes it look a little bit different. Because really what it's saying is I'm going to square the 3 first, and then I'm going to make it a negative.
5.
And that might be a little bit of a different plots.
And then go up.
See how all of it is negative now?
That's your new y.
Every response is negative. That's what's showing all that.
And then what I have to do is a little table.
So even though
point
x
in the
is
center of the
positive a
table,
little bit, then it keeps
You
going.
do
Does that look like his?
2 after. And then you should have
Asymptote is -4, the asymptote is at
dying. I see.
0.
Well, so what I did is I also like how we know the back screen lighter or darker. I can calculate this off the battery. Longer, it makes it a little bit lighter. So just do that. Type it in. So effectively, just like you have it, clear. 1/2 2d. Pretty good. So there's your exponent.
Let's try a couple. It'll help me out more. You teach me so I can remember how to do
Just one
this.
thing.
Need some help, Mr.
All right, let's give it a shot. Coming right over next.
Yes.
Well, what we really need to do is make
So now
sure
what you really want, I think, on the second
because this will do all the work. Let's use this. Let's make it easy.
Parentheses x plus 4, x plus 5. X plus 5 all in one parenthesis. Whole point x plus 5.
Okay. So the beautiful thing about what you guys are learning is everything.
I knew that. What do you need help with?
Okay.
So it's left 5, yep, and that's right. So the original function you're given here is, right, that's the original one. And you got to transform this using left 5 and up 4. So left 5, oops. That means you put the x plus 5 in place of the x. Okay? It's inside the function, right? So replace it. I'll be right. Oh, you have trouble? Oh, it died again? All right, hang on. I got you. All right, and then at the end, on the outside, there's a plus 4, right? So we'll just put a plus 4 here on the outside, and there it is. That's your function. Okay?
Figure it out. Then we're going to do the.
You okay, Trey? You sure you Trey? You sure you're Trey? You sure you're okay?
Let it grab.
Can I borrow a wrapping calculator? That will be
Let me see here.
Let's do it.
Yes. Yes. Go ahead. Just get a drink. Come back. Yes.
All along the 0. So like. And it's got the curve up. And
All right. No, I gave you this one before. I know it was causing trouble. Let's see if it does it again.
See how that's x plus 1 in there and plus 4 on the outside.
No, it did not.
Okay.
That's how it was when I first got
Oh, I know what we're saying. All right, so this must have sort of 4 next to that. And we didn't want it, so that this.
Okay. Looks like it's working okay. See if it gives you any trouble. I'm Mr. Whitlock. Nice to meet you.
Exactly right. But how would you put your original here? It's 2 is on the outside. It's 1/2 is the base of x. So make 2 on the 1/2 to the x plus 5. You just put in that and left the 4 off. So what's up? It'd be 2 plus 5. Yeah. Like that. You raise it up and look like you have the x. It's the x. It's 1/2 of x. They have no x plus 5. I'm not sure what you're trying to find. is this line. So let's get our calculator. So let's ask Mr. Whitmire how to do these over calculators. I don't know how to do that over calculator. How to
The parentheses make it work and stuff like that.
But then also jump out of it so that it's
So, okay. Just arrow to the right. Or teacher, now you're out.
This is like so easy.
Yeah, I got you. Here you go, Sierra. Right. Jackson, how we
I think we've done both.
Yes, sir.
Oh, that's exactly right. You have a technique, right? Coach Seaver's a really smart guy. He's a good mathematician.
Oh, that's because your window is all funky. When you zoom and then go to standard. Is it about math? Fantastic. See it. And then
I did realize.
when you get the function, all the pieces there. So, this was your original function. Okay,
Right.
here we get a different original function. This one.
Okay, how are we doing on graph on this thing? Are you getting okay? Because I just had the other
Take
calculator.
this function.
Where's your graph? Can you please do
Well, you have
that?
f of x.
Not that.
Get this.
This.
So this is saying f of
I'd like
x
to see
plus 5.
this.
So in other words, the x that's here, right, is being placed with an x plus 5.
Okay, so like,
so that means this x.
this one is saying
the
the
opposite. Okay, so the opposite of y is going to be the half. They go instead of an x.
Alright.
This is going to be
I like what you're doing here, but I think with this, you should have seen
And
something
then
around
the function, we have the function out.
should have been risen up to the 4 and done like that. Okay, because that little indication of R4 tells me to push it up. So, but on these calculators, it's harder to do that. Yeah, can you move that away? Whose phone's that?
Okay.
Whose phone's that?
A number on the end tells you to shift up or shift
No,
down.
it's math. Watch baseball.
So that plus on
You better call somebody to listen to you because I don't care about that. You have a job to do. Alright, so which one are we raising up?
So no
Get
down
that?
because it's
You did this part, that's the
what's this x plus 5 going to do? We'll go
So
back.
then I'm plugging in here with the, it has to be, but it has to be 2.
Yes.
And then, don't forget last thing, but you're substituting that in brackets. Yeah, so 2 and 1 divided by 2. And parentheses.
The number that's in with the x
And that's raised up. Now plus 5 is the 11. Yeah,
okay? On the outside, it does do it with respect. Up 4 or down 4 plus 5 4. Okay?
And you should see it
Now,
this should be
so real quick, so get rid of our here.
So beyond that 0, when it becomes positive, and you see x is 1, 2, 3, all the answers have
I just got to shift up 4. So 1, 2, 3, 4, and left 5. 1, 2, 3, 4. It's a lot.
Because I don't, then you'll just frustrate. Then you'll just frustrate. And I don't want to frustrate. Yes. Okay, what are we practicing on? We're practicing? Feeling good? Because I see this on the quiz.
How we doing, man?
What about you, my man? I should see it come up 4. Make it negative 2 and a half to the x power. Okay. Plus 5. I don't know. That looks right because of that. That looks right because of this. It looks right off the top of my head.
I got 4.065.
She went away. Why you run away? No, bro.
Who's going to be?
Don't really need it. Yeah, so I want, they're basically saying substitute this in Did you? How are you feeling about it? For you, a little better? So these are all giving us all originals. Let's go back to the original line.
Look at the end game now. Once you jump,
I want to know. Let's do the original. Let's do the original line is negative 4. And this is
How are you looking, Mr. Stever? I think you're getting there. I think you're getting there too. I think you're getting there too. All right, like 1 more minute. We're going to go over these. 1 more minute.
So in other words, that's what
Yeah.
you know what? Duke should have lost. Duke should have lost.
Fill it in. It's crazy, Eric, I know. All right, folks, let's get back on track, okay? Whew, it's getting a little crazy in here. All right, but I've been seeing a lot of good stuff too, so good job, okay? Good job on the hard work and stuff, because I really do feel like we're getting this all right, so that's great. All right, let's take a look here at our 2 functions and see what we came up with. All right, if you didn't get them both done, you can write them down while I'm working on them here, okay? So let's go to Alexia. Alexia, our new function here. Were you able to come up with the new function? Shh. It was 2 times 1/2 to the what?
we're rewriting it.
Shh. Okay, so x plus 5 here, Alexia, writes inside the function, right? If you look here, we had f of x, and that gave us 2 times 1/2 to the x. Shh. Listen up, girls. So we replace the x with an x plus 5. So that means this x will also get replaced with an x plus 5. Okay? So it's just going to be to the x plus 5. And the plus 4 is on the outside, so we put a little plus 4 on the outside. Okay? You see that okay there, Alexia? That's what you need to do. Okay? Shh. Alexia, were you able to identify the transformation? Okay? So let's go to someone else then. Let's go to Olivia. Olivia, what's the transformation here for letter B? Left 5. Up 4. Okay, now, folks, I said this yesterday. I'll say it again today, right? What are we shifting first? The most important point of our exponential equations is the y-intercept, all right? When we were doing parabolas, the vertex, right? The bottom point of the parabola or the topmost point, depending on where it's oriented, right? For the exponential, it's the y-intercept. All right. What is the y-intercept of this function right here? 2. It's the A value, okay? And then B is the 1/2 there, but A is the y-intercept. So we'll put our pencil point here at 2, and then I'm going to use my transformations. Left 5. So 1, 2, 3, 4, 5. Up 4. 1, 2, 3, 4. There's my new point. This is my center point of my table. Okay, so we'll put the -5, 6, and then we'll do 2 points after it. Okay, so just x values before, so -6, -7, x values after, -4, -3. Okay, and then you can go to your table and fill it in. Oh boy. Please pause while there we go. Fill this in. Okay, so -7, we get 12. And -6, we get 8. And -3, -4, we get 5. -3, we get 4.5. Okay, and we're just going to plot these points. Now, I can't plot -7, 12. It won't fit. -6, 8 also won't quite fit, but I'm going to kind of fudge it a little bit here. We'll say it goes right there. -4, 5. -4, 5. Okay, and then -3, 4.5. -3, 4.5. Okay, now, before I go ahead and draw this curve, I also want to identify my asymptote. Now again, what was the asymptote for the original function? It's at y equals, for the original function. For the original function, it's where? Not 1/2, nope. This one's not shifted up or down, it's at 0. This one's at 0. Okay, but then we shift it up 4, and now our new asymptote is where? If it was at 0 and we shift it up 4, we're now up at 4, right? So horizontal line through the 4 there for that asymptote. Okay, and so our curve's going to kind of come down, connect these dots, but we won't cross that asymptote. Right? We're just going to kind of approach it. Okay, like so. So 4 is the asymptote. Okay, which means the range then, Dawson, what's our lowest y value for this graph going to be? 4. And what's the highest y value we're going to go to, Dawson? Infinity. Good job. Okay, perfect. All right, next, letter C. All right, let's go to Ethan. Ethan, what's my new function going to be here with -f of x?
-2
Parentheses.
1/2 in parentheses x.
Yes, perfect. Good job. All right, very good, Ethan. Thank you. Let's go to Braden. Braden, what kind of transformation is that negative going to do?
Make it go lower.
Okay, flip over your paper there. Take a look. What's the negative in front? It's on the other side of your paper. What's the negative in front of it? No, it's on the other.
He has it written down.
What's it do? It goes lower? Is that what he has written down?
No.
Kaylee, point out. Look at what you wrote there. What'd you write?
Oh, it reflects.
Oh, yeah, that's what I wrote. Yes, reflects over the x-axis. All right. Thanks for the assist there, Kaylee. Thank you. All right. So now, reflect over the x-axis. Okay, good to know. So again, what was our y-intercept for this function again? For this one? It's the a value. It's the a value. It's 2. It's 2. Okay, that's the y-intercept. But we're going to reflect it over the x-axis. So that means it reflects to what? -2. And so when I make my table, okay, it's -2. Whoops, it's 0, -2 there in the center. Mr. Wid, narrowly avoiding a mistake there. Okay. So we'll pick some points before, we'll pick some points after, and we'll figure out what those other points are going to be. So -2.5 to the x. Okay, so for -2, I get -8. For -1, I get -4. For 1, I get -1, and then for 2, I get -1/2. So we'll plot those points. -2, -8. Doesn't quite fit, but again, I'm going to fudge it. 7, 8. Lay them straight. All right, -1, -4. Then we'll do 1, -1, and we'll do 2, -1/2. Okay, now, again, before I connect the dots, let's worry about this asymptote. The asymptote. What was the asymptote for the original one? 0, right? And if I reflect it over the x-axis, where does it going to reflect to? If it was at 0 and I reflect it, where's it still going to be? Shh. Thanks, guys. It's going to be at 0. She did. Reagan. Good old Reagan. Okay. There's the graph. Okay, so the asymptote is still at 0. Okay, and let's see, our range. Who's going to help us with the range? Ooh, Sierra. Sierra, what's the lowest y value this graph's going to be?
Negative infinity.
Yes.
0.
Oh my gosh.
I got something right.
You got something right. No, you got more than that right? You got more than that.
Yes, Sarah.
All right, very good. That's right. Questions on B or C here. Questions on B or C. Are we done for the day? No, we've only just begun.
No, we did not.
I'm going to give you guys your homework assignment now. Okay? So, yes, homework. Sorry, yes, Pat. Okay? So, for the remaining time in class here, I'll let you hold on to it for right now in case you want to use it during the review. Okay, listen up, folks. What I'm passing out, it's like it, yes. It's grippy, that's all. I'm going to pass out our review for tomorrow's quiz. This is what I want you to work on for homework tonight. Okay, if you don't finish it for homework, that's okay, because we're going to work on it in class too. If you don't feel ready for it, absolutely not. I just got like these two. So, all right. So this is what I want you to work on for the remaining time in class here, folks. Okay, remaining time in class. I want you to work on this.